Hello class, in this lesson we're gonna learn the position of linear function graphs relative to one another, which are really common in algebra. Let's write here the formula of linear function. Y is equal to kx plus b. So let's solve under what conditions are two given functions parallel. It's the first type, our topic. Let's write two functions here. Y equal to 2x minus 3 and the y is equal to 2x plus 1. But in this case, the values of k of the two given functions are equal. You know what the k? K is a coefficient in this functions. K first and the k second are equal. We can see here our coefficient is at 2. They are same and the k is equal to 2. And we have b1 and b second. And b1 is equal to minus 3, b second is equal to plus 1. B, it's a free member, but they are not different. They are not same. They are different numbers. So now let's see if these two functions are placed in parallel. These two functions in parallel. First, we give only two values to the given function in the table. Let's write table here, x, y. And that is to draw a line in the coordinate plane. It is better to draw only two of its points. 0 and 1 are the easiest. So let's write here 1 and 0. Let's check this. Y is equal to 2 multiply 0 by minus 3. Y is equal to minus 3, and then y is equal to multiply 1 plus 1. Y is equal to 3. Minus 3 and minus 1. Okay, good job. Now let's write the second function x and y. 0, 1. Y is equal to 2x plus 0. Y equal to 1. Second, y is equal to 2 multiplied 1 plus 1. Y is equal to 3. No, here I have a mistake, sorry. Y 2 multiplied 1 minus 3. Y is equal to minus 1. Yeah, right. And here we write 1 and 3. Now let's put the values in the coordinate plane. Y, x. When the value of x is 0, the value of y is minus 1. All with such logic, guys. If x is 0, then y is 1. Now I will highlight the value of the second function with a different color. Let's write the first function's graph. And here, no. The first functions draw. Here we can write here if x 0, then y is minus 3. If x 1, then y is minus 1. Yeah, you're right. And here will be point, and here will be point, minus 1. We can draw like this. We can draw like this. And this is second function's graph. It will be here. If 0, x is 0, y will be 1. And if x 1, 0, y will be 3. Here we can. And we will draw like this. The function of first graph, don't forget, it's this one. The second graph is this one. And now, here we can see that the two lines do not intersect. First graph function is y is equal to x plus 3, minus 3, sorry. The second function is x plus 1. If the value of k of the given function is equal, it means that the straight planes are located what? parallel. This one is parallel graph. And now K1 is equal to K2, and so that's why Y1 is parallel Y2. The first part is over, and the second part. And now let's look at the situation where the values of k are different. This is our second part. Given function is y is equal to 3x minus 6, and then y is equal to minus 2 over by 2 and x plus 1 And if the value of k are different, it intersects in the graph. To find the intersection point, we can use analytical method or graphical method. Let's use the analytical way. After we will solve by graphical method. We know that y is equal y, and so that's why 3x minus 6 equal to minus over 2 plus 1. 1, and we can, and the axis from the to the left side, and now axis to the left side we will write 3x plus 1 over 2x equal to 1 plus 6, and 3.x is equal to 7, x equal to 2. And now we found x. Now we can put x in the place of any x. Let's check this right here. We have a function, and y is equal to 3. To the x, we will write 2 multiply 2 minus 6. Y is equal to 0. And the second, minus 2 over multiplied by 2 plus 1. It's equal to, we can simplify here, minus 1 plus 1 will equal to 0. And then the point of the intersection of these functions are 2 and 0. Now let's represent it in the coordinate plane. Let's write here. And we have, it's enough for us to find only 2 values of each line in the coordinate plane. Let's put 1 instead of x. 1, x equal to 1, and y is minus 3. It's x, it's y. So we have the x, it's a 1 here, right here, and the y is minus 3. And we have the point here, and here we see the coordinates of the intersections point. Here we can first point, and we can draw the line, and the second is 1. Put 0 instead of x, then y will be 1. 0 is x and y is 1. Here we can draw the point and draw the line like this, and the intersections point. Here, intersection point. Now let's graph this is a graph of the functions, and it's called intersections point. That is the word that passes through the points on the 0 and the x-axis. Intersections point of this graph is 2 and 0, and we can write like k first not equal to k second, y, y first, r intersection, 2, y, y 2. And we can, this part, we can write like A or B, what you want. So I will write like A. A is X and Y. So it's end of second part. Now let's look the third part. It's a perpendicular. The third case is perpendicular, and the given function is the y is equal to 3x plus 9, and y is equal to minus 1 over by 3 multiply x plus 7 3. For the first function and the second function to be equal, k first and the k second must be equal to minus 1. Let's check this. K first is 3, k second is minus 1 over by 3. And now 3 equal to minus 3. We can simplify this there, and it's equal to minus 1. And this we proved that k first and k second is equal to minus 1. We can and now let's let's draw the graph here. And we have a 3 minus 2, and here we have the points. If minus 2, it's to them. Let's write here 3 minus 2 plus 9. It will be minus 3, right? Or plus 3. Plus 3. Here will be point, and then here will be point 1 point. It's one. It's first. And now we can draw like this. It's a line, but okay, that's okay. And here we can write 1 point. It will be a perpendicular function, and this function is equal to minus 3x plus 7 by divided 3. And as we can see, the here we have 19 degrees. As we can see with ruler, the angle between them, between this one, is 19 degrees. And it means that they can be perpendicular. We can measure their perpendicular with a ruler. And and that's all. We have considered with you the positions of linear function graphs relative one another. So we have 3 ways to find them. First parallel, second intersecting, and the third perpendicular. If k is greater than 0, then parallel graph will be acute angle, and if k is greater than 0, then intersecting graph will be obtuse angle. So thank you for your attention.